So this is a forward research module about bioinformatics training, and the title is Ingenuity Pathway Analysis. So as we know, IPA is an all-in-one web-based or cloud-based software that will allow you to analyze, integrate, and understand the data derived from gene expression, the microRNA, and SNP microarray, metabolomics, proteomics, and RNA deep sequencing experiment. Those data will come from your own data or the data you collected throughout the databases. And you just need to upload the IPA and use IPA to analyze. The second feature that IPA will provide you is help you to search for all the information that is right now available on PubMed. They will collect all of the information and build them to a system, allow you to very easily and rapidly collect and understand about all of the information you need on the gene interest. So you can check the gene proteins, chemical, drugs, and also you can also build the pathway and interactive model for your experimental system. This is the website of IPA, and originally they only have one product, which is named IPA, and the company name is Ingenuity System. It's based in California and has been recently bought by Quasion. So IPA is the first product of that company, and now they have certain service, which is called iReport, and also the variant analysis. So today we focus on IPA, which will allow us to have a comprehensive pathway and network analysis of complex omics data. If we don't know how to use IPA and have a lot of money, you can send the data to Ingenuity system, and they will create an iReport for you. So this is basically like you pay them money and they do the analysis for you. iReport service will give you the same data as IPA, but it requires some training. Variant analysis is a new service and allows you to rapidly find causal variant using a knowledge-driven approach. In other words, for example, you have a disease, you are studying a disease, and you don't know what is causing the disease. Then variant analysis can help you identify the candidate genes responsible for that disease. Second thing is, if you want to identify a biomarker, then variant analysis is also a very good tool for you. So again, IPA can help us for biomarker discovery, and also very useful to analyze metabolomics, which is basically the metabolism profile of the cancer cells. We can also use for microRNA research as well, and for the omics, toxicogenomics, transcriptomics, and causal network analysis. So basically, IPA can analyze anything, any kind of data that's right now available for life science researcher. So IPA is a very useful tool for cancer research. And as I mentioned earlier, we need to collect the data by ourselves, okay? And we will follow some basic statistics like doing the macro correction, normalization, calculate the p-value, or do the SNP call, etc. And once we have these raw data ready to upload to IPA, then we just register our IPA account and then upload those data. And IPA will help us to analyze the biology and to visualize the data in context, meaning that you can export those data as a figure for your paper. IPA is a pretty young company, but they have been widely adopted in the scientific community, especially in the US and Europe. And it is a number of papers that have used IPA in the research. It's about almost 9,000. And IPA, like I mentioned earlier, can analyze simultaneously multiple type of data. For example, like genomics data, transcriptomics, proteomics, metabolomics data. So this is a very good tool for you to have a systematic view of what's going on in the cancer cells. And IPA can also help us to determine the causes of tumorigenesis or any kind of disease. And this is the image I took from the website. This is a little advertisement, but I want to show you how powerful IPA is. It's basically, they call it can unlock the value of your serum, what I say. So there's multiple ways to use IPA and also multiple tools. This first one, they claim they are the market leading pathway analysis, but right now on the market there's a couple of pathway analysis. You know, when we study the cancer cell signaling, we need to have a pathway analysis because we need to look at the gene expression at the DNA, RNA, protein level, not just that gene, but also all of the genes related to that gene as well. We can also use IPA to predict causal analytics. For example, like predict what is responsible for the disease or that phenomenon. We can also use IPA to analyze the RNA-seq data as well. So again, IPA can be used for multiple types of analysis like transcriptomics, biomarker discovery, microRNA research, proteomics, etc. And this is what they claim. So after we have made all these findings, IPA will collect all the papers in PubMed, put them into the system, and after that, they use those systems as a filter. And this filter will be very useful for us to filter information from our data. So it's a very complicated system, but when you look at this, okay, this is the pathway analysis. For example, in this case, they analyze the angiogenesis genes and the microRNA that is deregulated in ovarian cancer. This is just one of the type of data you can get from IPA. So you can see this is a very informative map, show you how the gene interact, for example, c-MYC and HDAC, and how the microRNA can target them, and also the drug as well. For example, here, this is the drug. They can target the oncogenes, or for example, here, HDAC1, etc. And the red and green color will be used for microRNA up or down regulated in that gene, that map. This is another map, they call it the causal map. So this map will help you to build the mechanistic network that will describe the possible connections from different genes. And usually, this is the most frequently used data from IPA. For example, if we upload a microarray data or cDNA array data on IPA, and we ask ourselves, what kind of systematic change will take place if I treat the cell with drug A, for example? And this is what happened. IPA will, so based on all of the information available in PubMed, we classify them into pathway and biological process. And they will use them to screen for your data. And after they display them as a heat map right here. So in this heat map, orange color represents upregulation. A blue color represents a downregulation. A white or gray, just minor change. IPA can also use to study the response of the cells to drug treatment as well. For example, in this case, they check the downregulation or upregulation of glutamate metabolism, or taurine or hypotonic metabolism, or mitochondrial dysfunction, etc., when they treat the cells with drugs. IPA can also analyze genomics data as well. For example, here to check the DNA copy number and also the RNA splice variants, protein domain, and also here this color over here represent the change at the genomic level. We can also use IPA to study microarray and the target of this microarray as well. I know this is a lot of information, but I just want you to have a brief overview of what kind of data you can get from IPA. So, in order to register for IPA, this is a link. So let me ask you a question. How many of you here have already registered for IPA and can log into the website? Could you please raise your hand, please? 1, 2, 3, 4, 6. Okay, thank you. Half the class. Okay. So now I would like you to, for those who have not registered for IPA, I would like you to go to this link and start the trial version of IPA. because in the second part, we will do a couple of practice with this software. So the first exercise we will do is to retrieve all information available on PubMed about P53, cyclin D1, cyclin E, using IPA. Second exercise is to study the connection between P53 and TGF-beta1 and identify all of the possible mediators for this crosstalk between P53 and TGF-beta1. Okay, so for those who have not logged into IPA, please do it right now. And for those who have already get access, please turn on your IPA, and we're going to practice right now. This is the home page of IPA software, and once you log in, this is the screen you will see. This is the big search box. This is where you enter the gene name or the pathway name. You can also enter the name of chemical as well, like the drugs. If you want to study the functional disease, then click the functional disease tab. If you want to study about pathway or toxicology list, then click here. For example, I would like to study, for example, like P53. It's a gene. Click search. So IPA will give me a couple possible options like P53 or P63, but they are in the same family. So just click here. P53. So once you receive a report from IPA, this is the first summary. This is the official name of P53, the same synonym. And also the domain of P53 protein, like linear binding domain, tetramerization, and transactivation domain, and also the function as well. This is a subcellular location of P53, for example, like centrosome, chromatin, linear replication, foci, etc. And this is a canonical pathway that involved in P53 signaling. For example, like apoptosis signaling, cell cycle, G1S checkpoint, colorectal cancer metastasis signaling. And this is the microRNA that is targeted, that is induced by P53 or the one that target P53, causing P53 degradation. And this is the downstream target genes controlled by P53, and this is the gene that controls P53. For example, like P53 has been known to be ubiquitinated and degraded by MDM2. That's why you see it here. P53 can also induce its mRNA expression and also tetramerase. ATM can also phosphorylate P53 and stabilize P53. E6 and also other protein and chemical can also affect P53 as well. This is the binding partner of P53. For example, MDM2, MDM4. MDM2 when it binds to P53 will cause P53 degradation. MDM4 when bind to P53 will cause P53 change in the cellular localization. And this is the role of p53, like apoptosis, cell cycle progression, proliferation, etc. And this is disease involved in p53. This is the domain of p53. You can see it have multiple variants. This is the domain of p53. The location. And this is other variant of p53 like delta, p53, gamma, beta, etc. Okay. And if we want to study human p53, just click human. And again, you're going to see a similar description, but more focused on human. This is the database information. This is the protein product, which is the amino acid sequence of p53. You have different isoform. This RNA transcript, RNA sequence of p53. So in case, for example, you would like to design the primer for p53, then this is a good source of information. This is description of p53 involved in cancer. This is molecular process. For example, like p53 can affect expression of 1,694 genes and can transactivate 278 genes, can activate 255 genes, affect the phosphorylation of 138, etc. So you see there's a lot of information you can find about p53 using IPA. If you like to study p53 in mice, then just click mouse tab. And similarly, you're going to have all of those information. This is sequence of p53 RNA in mice, and this is the gene level. Okay. This is molecular process, meaning that p53 can affect expression of about 1,000 genes in the mice, etc. Okay. So now I would like you to do the same thing. Log into IPA and retrieve all the information about cyclin D1. I know it takes some time for us to turn on IPA, so please take your time. If you have any questions, please raise your hand and we'll be happy to answer.
Em đợi xíu. Nói chung cài IPA mất khoảng 10-15 phút. 15 phút nếu như bạn chậm thì 15 phút. Đi ha. Em vào được chưa? Sao các bạn này không có hỏi gì không? Thì các ông tô mai mới yêu cầu là email của viện thôi.
Mà nó cho 3 ngày xong rồi đăng ký xong nó không qua lại.
Ủa gì vậy? Em có email khác không? Đăng ký cái mới. Đăng ký một cái email khác. Có email khác, email cá nhân thôi. Được.